Hello everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this January 2026 lecture series, we are going to discuss about signals and noise in the measurement in biomedical transducers and sensors. First of all, why do we need transducers and sensors? We know that sensors are used to sense the environmental conditions and transducers which converts one form of energy into another form. With the help of sensors and transducers, we can get accurate results in biomedical instruments and equipments. Okay, then what is the role of signal and noise in the measurement? Signal is our input signal, our output predicted signal, and noise is some unwanted things present in our signal, our input, our unique component. So we need to eliminate noise for getting precise outputs at the end. See, first of all, here our empathy part. Uh, First, to understand biomedical signal and noise, and we know that biomedical signals are measurable signals, electrical, mechanical, or chemical manifestations of physiological processes within the body, which includes ECG, EMG, EEG, and we have noise, and this noise. This noise may include corrupt diagnostic information, mask weak physiological signals, compromises the clinical decision making, and it affects the treatment outcomes. Our signal, which is present in ECG, EMG, EEG, or any physiological signal, blood pressure, temperature, chemical markers, the noise in measurement which affects the biomedical signals in the way of corruption, masking, compromising, and it affects the whole treatment outcomes. So we need to eliminate it effectively. See here the types of noise and source in biomedical measurements. Here we have external noise, internal noise, and interferences. External noise, some atmospheric or man-made or extraterrestrial noise under external, and internal part we have thermal noise, short noise, flicker noise, and popcorn noise. And interferences, sometimes we have power line hum and electromagnetic interferences, or else we'll get motion artifacts from patient or electrode movements. See here the impact of noise on biomedical signals. This is our defined part. Here, signal distortion mechanisms, and for this, I've included one real world example, EMG contamination, and here we'll get clinical consequences. See here in signal distortion mechanisms, here the noise adds unwanted components to the measured signal. It alters amplitude, frequency content, and temporal characteristics. Here, our real world example is EMG contamination. Here, in this electromyography, the signals are particularly vulnerable to contamination from ambient electromagnetic interference, motion artifacts, also electrode skin interference, and noise. Here, these artifacts can completely obscure muscle activity patterns. See, here are clinical consequences. The presence of noise, it leads to misinterpretation of diagnostic data, so which leads to delayed or incorrect diagnosis as well as compromised patient care decisions. It totally collapses the treatment. See, noise reduction techniques in biomedical signal processing. Here in this part we have analog filtering, digital filtering, signal decomposition, and hardware optimization. If you want any clarification, please refer our previous lecture series videos, which includes biomedical signal processing concepts and application of BSP in healthcare. See, here I've included one activity. See here, first thing, to analyze the scenario, take any clinical scenario, and in this identification task, students are the members, they must identify the types of noise present, and they may suggest or they may submit a proposal for noise characteristics, And finally, we'll do some group discussion to understand the noise and signals present in the measurement. See here in this assessment part, the first question about noise classification, and the second one I have included for common noise sources, and third one for filtering importance, and fourth one is EMG electrode placement. See the summary. In this biomedical signal measurement, we have discussed about the signal types ECG, EMG, EEG, BP, and other physiological parameters, noise types, external, internal interference, noise sources, environmental, instrumental, and the reduction part we have filtering, processing, and hardware. And here our key takeaways are noise is inevitable but manageable, and advanced signal processing enhances the fidelity, and knowledge drives gives effective solutions, and the design and placement it matters a lot. Here I will include some references. Thank you. Thank you all.